In this section, we're going to be learning about informalizing slope of a line and finding out how to find slope when given 2 points and not just a graph. So it's important to know that the definition of slope is that it's the ratio of a line's vertical change to its horizontal change. So we're going to be talking about up, down, distance, and left, right. Or remember, rise over run. The ratio tells us that it's going to be a fraction, vertical, up, down, horizontal, left, right. And so to find the slope of a line between any 2 points, we count the distance vertically and horizontally, like here, 1, 2, 3. That would be my rise, and my run would be 1, 2, 3, 4, 5, 6, and then I would reduce that for a slope of 1/2. There are 3 slope formulas that are used most often. The first one we've seen a bunch, it's rise over run. Another one that means the same thing as rise over run is change in y over change in x. You'll notice that this symbol right here, that's a triangle, it's the Greek letter delta, and it means change in. So this is read as change in y over change in x. And then the last one that we're going to see today for the first time is, I call it the subtraction fraction. It's y2 minus y1 over x2 minus x1. Notice that these are subscripts, not exponents. They're written below. They just denote the second y coordinate and the first y coordinate, second x coordinate, and the first x coordinate. And m is our variable that we use for slope. So here we're just going to practice reviewing finding slope on a graph. So for the first example, I would count 1, 2, 3, 4, 5 up, and 1 over, 5 over 1, which would reduce to 5. And then I also pay close attention to my sign. This slope is increasing, so it's positive, so I don't need any extra symbols to say that that's a positive slope. On the next one, I would go from this point, I would go 1, 2, 3. That would be my rise. 1, 2, 3, 4, 5, 6, 7 would be my run, so 3 over 7. And then paying close attention to my sign, I can see that this has a negative slope because it's decreasing, so I would include that negative sign to denote that. Pause the video, try examples 3 and 4, press play when you're ready to check your answers. So here I had a rise of 2 and a run of 3 for a slope of 2/3, and it was positive. This one you might have found a little bit more difficult. You had to first find 2 points on the line, and so I used these points right here. You might have chosen different points, and I found the rise to be 6 and the run to be 2, which reduces to 3, and then I also pointed out that it was a negative slope by saying -3. Maybe use this point here and this point here. Either way, the cool thing about a line, what makes something linear, is that regardless of which points you pick, any 2 points on a line, the slope between them will always be the same. So now we're going to figure out how do we find slope if we're given points and not a graph. Well, we could create a graph and plot these 2 points and then do rise over run, but that would take a while. Or instead we can use the subtraction fraction. So it says to do the second y coordinate minus the first y coordinate and the second x coordinate minus the first x coordinate. It's kind of like, think about if you go to the doctor and you have your height measured, you'll find your change in height by doing your old height minus, or sorry, your new height minus your old height. I like to do the subtraction fraction where I put my m equals and then I draw a fraction bar with 2 minus signs. This helps me make sure that I fill in the data in the right way, especially if there's negative numbers. The other thing I like to do is I like to label my ordered pairs. So remember, ordered pairs go x comma y. Now 10, 3 happens to come first, so those would get the 1s and these would get the 2s. So in my formula it says to do y2, that would be 6 minus y1, that would be 3 over x2, that would be 5 minus x1, that would be 10. And so then I would just do this math, and so I would get 6 minus 3 is 3, 5 minus 10 is -5, and I would like to write that as -3/5. I just think it looks a little nicer when the negative sign is on the top. Let's try example 6, and then I'll have you do some on your own. So again, I'm going to start by doing my subtraction fraction, and then I'm going to fill in my information. So I've got 8 is an x, 4 is a y, 10 is an x, 2 is a y. These are my 1s, these are my 2s. So on the top I do y2 minus y1 over x2 minus x1, and I would do that math. And so I would get -2 over 2, which would be a simplified slope of -1. So at this point you're going to do examples 7 and 8. Actually, let's just do 7 and 8. Pause the video, press play when you're ready to check your answers. So in example 7, I've got -1 minus 2, which would be -3, 4 minus 5, which is -1. A negative and a negative will divide to a positive for a slope of 3. Here I've got 6 minus 3, which is 3, 4 minus, and then x2 is -2. So notice that just because this is minus, this number can still be negative. And then to do minus and negative, I add, so I would get 6, and 3 6 would reduce to 1/2. Now examples 9 and 10 are just two special cases, and so we'll still use the same strategy of our subtraction fraction. It's just that when I plug in my numbers, 6 minus 6, I'm actually going to set them both up first, and let's see what they have in common. So I'm going to get 0 over -2, and then over here, I'm going to get 8 minus 6 and -1 minus -1, and so on this one I'm going to get 2 over 0. So you'll see that they both have a 0 in there, and what we want to do is simplify that. So a calculator can help you, but just be a little bit careful. If I type this into my calculator, 0 divided by 2, it's going to tell me 0, which is great. And if I just show this on a graph, I just want to show this really quickly, so I would go over 4 up 6, and over 2, it's kind of not drawn to scale, over 4 up 6, and over 2 up 6, and if I were to connect those 2 points, I get a horizontal line which has a slope of 0, so that's good. Now if I were to type this into my calculator, it would say error because we can't divide by 0, so we can't have error for a slope, but let's see what this would look like. So it would be -1 6 and -1 8, and then when I graph I get a vertical line, and a vertical line, we're going to do more with this, but a vertical line has a slope that is undefined. And so one little trick I like to use besides the calculator, which again this will actually give me an answer of 0 and this will give me an error, is if the 0 is under the line, it's undefined. The last thing we're going to do with slope is rate of change, which is simply just slope in the real world. It has context, so we're going to have units, and often it's going to be expressed as a unit rate. So here we have an example. It says a tank of water was being drained at a constant rate, and the table shows the number of gallons of water left in the tank after being drained for two amounts of time. So after 10 minutes of draining, there was 450 gallons left in the tank, and after 30 minutes of draining, there was 330 gallons left in the tank. So you can see that as time is going up, the gallons is going down, which makes sense because it said it was being drained. So for this one, I'm actually going to use my, I'll do it down here. I'll use the formula we haven't used yet of change in y over change in x. And so if you think about input and output, remember of a function, x is my input and y is my output. And so in this case, the thing I'm starting with is going to be the time, and what's coming out of that is going to be the amount of water, because the amount of water left is going to depend on the amount of time that we've been draining. So my change in y, the water is going from 450 to 330, and so that's a change of -120. I want to make sure I write the word gallons because that's going to give context to this problem. And then for my change in x, or my change in time, it's a change of 20 minutes. And again, I want to make sure those units are there. So that tells me that in 20 minutes time, the tank drained by 120 gallons. We could kind of get that from this table. So what we're going to do is we're going to simplify that to a unit rate to find the rate of drainage. And so I can divide top and bottom by 20 to make that a denominator of 1. And if I were to divide -120 by 20, I would get -6. And so what this means is that this tank is draining at a rate of 6 gallons per minute. Lastly, we have Paul wrote the equation T equals 2m plus 40, where T represents our temperature in Celsius and m is representing how long the substance has been heated for in minutes. So let's describe the relationship between the temperature of the substance and the time it's been heated. So the temperature was initially blank degrees Celsius. The temperature increased by blank degrees Celsius for every blank minute it was heated. Pause the video, pick your best answer, and then press play to see if you're right. So this is going to mean that our temperature was initially 40 degrees and that it was increased by 2 degrees for every 1 minute it was heated, and you can think of the slope as being 2 over 1, which if you're wondering where that 1 came from, remember we can always change a slope to a fraction by putting it over 1.